So here's just an example of what I'm talking about is if you were to go into a utility today, when you start looking at asset information, you would see multiple sources of asset information, like circuits are a good example. How many circuits do you have in your utility? And it depends on who you ask on what that answer is going to be. You know, if you ask your design engineers, distribution planning engineers, they will give you an answer. If you talk to your SCADA engineers, they'll give you another answer. It may not be the same. You talk to your relay engineers, they know how many circuits they are protecting, and so they'll give you an answer, and it's probably different. So that's the point, is there's multiple versions of the truth here, and so you need to have a structured approach to managing information across your utility enterprise. So in this case, in this example, we look at a designer creating a new line extension in a design tool that may be connected to a GIS environment. And so what happens here is a GIS designer will create a new line extension, and that would initiate a new message format that may be proprietary to that application. And if that's the case, that's okay. We can build an adapter that would support a standards approach to that data modeling and leveraging some of these emerging NIST standards, which in this case, looking at common information model as a standards approach to structuring that data. So this would be a model of how to structure data for common utility applications, and that's IEC standard 61968, 61970. Other utilities have standardized on multi-speak, and so that's the kind of thing we're talking about is leveraging industry standards here. And then across the enterprise service bus, that SIM-encoded message gets validated through these information services, which looks at, is this a valid line extension created from a valid application and a valid user? So it's got basically the checks in place, automated processes to understand who is allowed to create new assets and the services associated with that, and who else needs to know that a new asset is created, along with a unique identifier so you can trace that back to that source, the workflows associated with that, and then stores those into staging areas that would have another process to validate and roll into production of those other systems. So that's a method for synchronizing data across your enterprise. So that's an example of a best practice of enterprise information management or a data management process. Another best practice I just want to share quickly is mobile workforce management. And you know, we've seen some real substantial workforce optimization, workforce efficiency value of mobile workforce management, of basically street-level routing and scheduling of the crew. So key benefits there in time management, crew management, but don't stop there. There's some key value you can get in information management of field data by building those workflows and those work processes into the mobile workforce management system. So the transferring of that information directly to the systems that need them, these configuration management settings, leveraging the device for the test sets, the real-time condition assessment during those major events, and then enterprise information management, the data quality aspect of that. So I'm going to just want to conclude with the value propositions of data management. And key value there, it creates ownership and responsibility at all levels in the utility. It provides a single version of the truth and unnecessary duplication and proliferation of that data. It reduces the number of and effort for integration. So instead of point-to-point, you know, virtually several thousand integrations that need to be managed, you're talking about application to application across the service bus. Flexible and scalable processes are built on key process management, provides integrity, availability standards, and applicable methods, metrics that go with that. So like timeliness, quality of that, how accurate this is, and so you've got processes in place to assure you're getting that the metrics that you've set out as part of these standards. And then finally, it creates an information architecture that supports a long-term vision of the smart grid. So instead of a point-by-point piecemeal approach, you're looking at it from a what do you want to end up with 10 years from now, and then as we move forward with these initiatives, how do we take a step towards that with each initiative. So that's what we're recommending as a best practice for information management. So with that, I think we've got another pulse question, Dave.
Yeah, thank you, Brad. In fact, there were a number of questions that were coming in about data accuracy, consistency, and reliability, and I think your summary and the whole topic was very right on about data quality. There's a number of master data management initiatives that are being driven out of the smart grid data management projects. This is just such a huge issue in the industry, so I really appreciate that, Brad. All right, so we're going to move to our next pulse question. So which best describes the status of your company's smart grid data management business case? And this really is where we start the process typically. And we're going to hear from Chris next, so this will help him understand where everybody's at today. And the four choices are: we don't have a data management program, we have a data quality process but no data management business case, we started a business case, or we actually have an approved business case. So if you can take some time to answer that question, that would be wonderful. By the way, we had great participation on the last one, and we appreciate it. And I think, Chris, during your discussion, if you could, I know you're going to talk about the whole process, but how you went through at Southern, deciding that data management was important, and how you were going to approach that, I think that would be great.
Okay, Dave, I'll make a note. Thanks.
Thanks, Chris.
Dave, we're going to go ahead and close the poll here, and then are you ready to share the results?
We are, yeah.
Oh, great. There we are. It looks like a lot of people chose number one there.
Yeah. And that's probably not very surprising. I would suggest that most of the clients that I work with do not have a program or a business case. So, Chris, it'd be very interesting to hear from you. And so it's my pleasure to introduce Chris Foretich from Southern Company. I've had the pleasure to work with him, and he's going to talk about their data management strategy approach.
Thank you, Dave. I appreciate that. Let me get control here. I'm going to start off just by giving a high-level overview of Southern Company in general, especially about what we're going to talk about today for those on the call who are just data management people, not necessarily utility data management people. And so today we're going to spend time primarily talking about our regulated utility business as it applies to smart grid and data management. And if you look at the chart here, the highlighted states on the map are Georgia, Alabama, Mississippi, and Florida. And what's important as it relates to the data management piece is a number of things. One is the size of the geographic territory, which lends itself to the number of the devices that we'll be installing on the grid, as well as the bottom left-hand side where you see that we have 4.4 million customers. So all of those components add complexity when we go to think about what we're going to do with managing all this data. So this slide is really talking about how we at Southern Company brand our smart grid efforts. There are really three components to that. On the left-hand side, we have the smart energy component. Really, it's the generation side of the business, or how we make electricity. What's interesting on this side is we're building new nuclear plants, as well as we have one of the larger solar projects in the country. And that's a lot of activity going on that all has to come into play with how we're going to set this architecture and collect this information. As we move over towards the smart grid side, most of the funding that came from the DOE for us is really around the smart grid side, how we transport this electricity from one place